In today's class, we'll look at the term generalization. In backpropagation algorithm, we typically start with training samples and then and use the backpropagation algorithm to compute the synaptic weights of the multilayer perceptron by loading as many training examples as possible into the network. The hope is that the neural network so designed will generalize well. That is, we provide the training examples to the multilayer perceptron, that is, assuming that it will generalize well to predict the output. That is, a network is said to generalize well when the input-output mapping computed by the network is correct for the test data. The learning process, that is training of a neural network, may be viewed as a curve fitting problem. The network itself may be considered simply as a non-linear or input-output mapping, because we map the input, that is a training data, to the predicted class, and then whatever it has learned, it should use that learned weights to predict the test data. Such a viewpoint then permits us to look at generalization not as a mystical property of a neural networks, but rather as the effect of non-linear interpolation of the input data. Non-linear interpolation is the process of estimating unknown data points, that is test data points, within the known range by fitting a non-linear function to the existing data. Existing data is the training data, such that the interpolated points form the curve rather than the straight line. Now, the figure here illustrates how the generalization occur in a hypothetical network, that is multi-layer perceptron or neural network. The non-linear input-output mapping represented by the curve depicted in this figure, that is, this is the curve what we have for a given training data. The figure is computed by the network as a result of learning the points labeled as a training data. That is, curve which is shown here is being computed or learnt by using the training data. The point marked in the blue color, that is here this one, which was not in the training data, it was a test data. And this point which is with respect to the test data on the curve generalizes the interpolated or performance of that particular computer. The point marked in the blue on the curve as a generalization is thus seen as the result of interpolation performed by the network. But when neural network learns many input-output examples, the network may end up memorizing the training data. It may do so by finding the feature due to the noise in the examples that is present in the training data, but not true of the underlying function that is to be modeled. That is, such a phenomena is referred as a overfitting or overtraining. That is, if the neural network learns from too many input-output examples, the network, instead of learning, it may end up in memorizing, memorizing the training data. And that situation we are going to call it as overfitting or overtraining. When the network is overtrained, it loses the ability to generalize between the similar input-output patterns. Here one example you can see, these are the training instance. That is, the curve should have been fitted to generalize to do the generalization of the learning. But here you can observe that is, it is being overfitted actually. That is, when the test data is being given, actually it is going here, that is the generalization point. That is, when the network is end up in memorization of the training data, we are going to call that as a overfitting data or over trained data. And you can observe that as, if after learning, if we get a curve like this for the test points, we are going to tell this as a good generalization. But after learning the training data, if the network ends up in a curve as shown here, that is, we are going to call this as a poor generalization. This should not happen. That is, the network should learn the good generalization of the training data rather than ending up in a overfitting data.